Thank you all for coming out. This is the title of my talk for today. But I have some alterations since I gave the title to the group here. So originally it was Sounding Out Modeling Orality for Large-Scale Text Collection Analysis. And it has become for today Sounding Out Modeling Aurality for Text Collection Analysis. And most of what I'm talking about will focus on aurality, so I won't really sort of piece that out for you right now. The large scale part I'll explain, and also I'll tell you how that fits in, but the reason it's crossed out is because we haven't gotten to that part yet. So I won't be talking much about that today. I just wanted to sort of, manage your expectations before, The use case that I will talk about today involves analyzing features of sound in text and audio recordings and considering the extent to which exploring these features affects our understanding of these cultural artifacts. This use case is supported by the Mellon Foundation as part of a grant titled SEASR Services, and it's being conducted through Stanford Libraries. Other collaborators include humanities professors from Stanford, George Mason, and the University of Illinois Urbana-Champaign. These include historians and literary academics. All of the use cases include research, and this is where the large scale comes in, on how humanities scholars can use textual analytics and data mining with visualizations to interpret large digital collections such as those represented by Google Books, HathiTrust, or the Internet Archive, among others. In particular, we're trying to show how humanities scholars can use SEASR. SEASR is a software environment for the advancement of scholarly research developed by the informatics experts at the University of Illinois Urbana-Champaign's National Center for Supercomputing Applications. I have to read that because it always trips my tongue when I try and sort of bring it out of my brain without looking at it. But specifically what I want to talk about today is how theories of knowledge representation have shaped the analytic workflows and interfaces we've developed to facilitate how we approach this study. The study came about because what I was seeing in some of the research being done on large-scale digital text collection analysis was primarily focused on words or n-grams, which is a number of words. And what I wanted to do, something wild and crazy, is I wanted to look at other aspects of text. I wanted to look at part of speech, rhythm and phonemes and stress and meter, and to see if we could do some large-scale text analysis, analytics, and visualizations on those aspects of text, because my thinking is, or my hypothesis is, that the way we're modeling our knowledge of text is limiting and restricting some of the questions we can ask because we're not modeling other ways of how we make meaning with text in various fields of study. So that was sort of the impetus for my particular use case. My particular use case is looking at a 3 Lives written by Gertrude Stein. There's a lot of scholars who say that she was influenced by German speech patterns, she was influenced by African American speech patterns, and so my thing was to say, well, can I model that by looking at, by comparing this text with a lot of other kinds of text to say which text it sounded the most like. It's a hypothesis. But in order to break down that hypothesis into a system for figuring out how to do that, I've had to spend a lot of time thinking about what is it that we're talking about when we're talking about the sound of text. And that's mostly what I'm going to talk about today. So relying on theories of knowledge representation put forth by computer scientists and AI experts, we've chosen to use the logic of aurality to model and analyze sound in text for this project. But before defining aurality for you, I find it useful to discuss why pronouncing a logic is useful for the project. John F. Sowa writes in his seminal book on computational foundations that theories of knowledge representation are particularly useful, quote, for anyone who is doing to analyze knowledge about the real world and map it to a computable form. And I think that's what we're all doing, so I really like that definition. In other words, theories of knowledge representation are transparent about the fact that computers afford representations, knowledge representations of how we think about the world. This perspective is important when developing projects that include computational analytics, since we realize that knowledge representations supported by computational analytics are unproductive if the logic and ontology which shape applications in a certain domain are unclear. So Sowa writes, quote, without logic, knowledge representation is vague. With no criteria for determining whether statements are redundant or contradictory, and, quote, without ontology, the terms and the symbols are ill-defined, confused, and confusing. And so what you do, what it comes back to, and again, what I'm talking about today is this idea of being transparent about your logic and your ontology, and in what domain you are having that conversation helps people understand what is being measured and what is being analyzed when you're looking at or you're using tools. And I think that's actually, a lot of people leave that out of their projects, really stating what it is they're measuring and what it is they're visualizing when they're showing you some visualization of text. So just to define some more terms, for Sowa, logic is pure form, and there's a much longer conversation about what that means, but I think it's a good way of sort of, blocking that out in your mind. Ontology is the content that is expressed in that form, and domain is the field of practice or the audience. And to better explain those terms, I'll give you an example from what I'm going to talk about today. So pure form, what we mean in this project by that is sound in text is oral, and I'm going to get to that in a second. The content, so if sound in text is oral, then the content that we're including in our analysis is things like phonemes, part of speech, stress, position of a word within a context, and whether that word is meaningful in a linguistic sense. So it's not just any old sound, it's a sound that immediately, there's a lot of theories out there that your brain does something different when a sound actually has linguistic meaning attached to it. Unless, like the sound of a car, you're going to react to very differently. Your brain's not going to react to it in the same way as a growling sound that also has the word, bear in it or something like that. That's part of this ontology. And then the field of practice is primarily literary linguistics. So that's the field of practice in which these parts make meaning for the most part. And so today, to kind of give you, in the remaining time, a sense of how this works in this project, I'm referring to another group of artificial intelligence scientists. You were also talked about, John Unsworth wrote a wonderful article in 2002 called What is Humanities Computing, essentially, more or less. And he actually does, I think, a really useful exercise, and I recommend it for others, by taking the 5 aspects of knowledge representation that are analyzed within this article and mapping it to a project to say this is where we're coming out with, this is what the knowledge representation is in this particular project. So I want to do that here, and then I've added in some domain because I think they keep that. I think they don't focus on that as much as Sowa did, and I think that's important. So the first thing that they talk about, their first aspect or role of knowledge representation is to say that knowledge representation is most fundamentally a surrogate. And I add, again, in some domain. And so here's where we start talking about, what do I mean when I say aurality? So aurality in this sense is the pre-speech promise of sound as it's signified in the structure and syntax of text. The structure and syntax serves as a surrogate of the sound's potential to be heard and understood. And this definition of aurality comes from a book that Charles Bernstein wrote called Close Listening. And he makes the sort of difference between orality and aurality as a difference of the sounding of the writing versus, that's aurality, versus orality, which is sort of the breath, is actually the performance of a poem. So if you think of a poem and someone's performing it, that ambiance in the room, the sound of the particular tone that person is using, the accent they may have, whether they're Southern or they're from New Jersey, all of those elements of the performance, the speech of it, the actual speech sound of it is orality. What we're talking about with aurality is the potential for speech. So the signs that you have in text that give you the notion of how you are supposed to pronounce something, not the actual pronouncement. And that becomes important in the context of this project because we are modeling the sound of text in the text in a way that the computer is going to read it. So this is the potential for how text could be spoken, but it's before it has been spoken. So it precedes speech, and this will make more sense in a moment. The second thing that Davis and his group talk about is a knowledge representation as a set of ontological commitments, and this is much like Sowa. And the ontological commitments that we are making here within the domain, this is sort of the domain within which this ontology makes sense, is phonetic symbolism, prosody and intonation, and speech perception. These are the sort of theories of how sound makes meaning that we are drawing from in order to come up with our ontology or the content of our oral representation of text. The third aspect for Davis is a fragmentary theory of intelligent reasoning. In some sense, this is the best guess, and I like the way that Bollinger sort of talks about how the sound of text is a best guess. And when you're talking about text, he says in the total absence of all phonological and visual cues, that means when you don't hear it and you're just looking at it, you're just looking at text, the psychological tendency to impose an accent is so strong that it would be done as a best guess from syntax. So what does that mean? That means that you perceive the sound from the oral logic that we're working from. We are arguing that you perceive the sound of the possibility of sound that text makes from the intonation, the stress, the rhythm, the phonemes, the vowels, and the consonant sounds, the position and context of a word. So if you know, typical Gertrude Stein, if I say, there is no there, each of those there's change the way you pronounce them. When you say there is no there, there's actually studies show that if you repeat a word over and over, the repetition of it, you pronounce it differently to make meaning. And so a lot of the way that we sound out things have to do with the position, it has to do with the part of speech, it has to do with vowel sounds. A lot of the work done in this shows that, that certain vowel sounds make you think that a word is pointing to something that is large or small. So peep, as opposed to large, like those sounds actually denote or connote this sense of meaning that you get from it. There's a lot of theories that go along with the sort of structure of where sound comes from. And finally for Davis, or not finally yet, but finally for Davis, this comes with a medium for pragmatically efficient computation. And what that means in the context of this project is that going with this logic of aurality or the sort of potential of sound, thinking about what that looks like in terms of the content that's phonemes and stress and vowel sounds and consonants, what computational analysis can we use in order to make that model with that content. And what we've chosen to include is an analysis software called OpenMary. And OpenMary is an open source text-to-speech system that essentially produces XML, but what it was made to do is to have a computer read a text and make an audio file of that text. And so what the computer is doing is making its best guess on a text to say, what does it sound like if someone were to understand it if they were listening to it? So the computer is making its best guess, and it's representing this best guess as an audio file that you can listen to, and so basically the text is being read to you, right? So what we've done is stop this process in the middle and produce or use the XML file that OpenMary is using to model those sounds, and we're using that within SEASR to perform clustering and predictive modeling on the preprocessed text. And I'll show you how that works in a second. But the idea would be essentially, one of the examples I probably won't be able to get to, but maybe, is that Gertrude Stein wrote, how many people have read Tender Buttons? It's taught in a lot of undergraduate classes, or maybe even high school. It's one of the few things that teachers feel comfortable actually teaching of Gertrude Stein. And one of the theories is that part of the reason that it's more understandable than her other things is that it's based on the sound of a cookbook. And so one of the use cases that we're looking at is, can you actually model the sound of Tender Buttons and compare it to the modeled sound of a cookbook and say whether it is or is not like this other thing. And I can show you the examples of that in a second. But so basically what we've done with that is Mary's best guess, again, is based on part of speech, position in the sentence type, various aspects of syntactic structure, is it a verb after a verb or multiple nouns? The information structure, is it a given or inferable information, is frequently deaccent. So basically if you say something like, if I were to go to the store, I would do this. Like there's stresses that you put on certain words as they come within independent or dependent clauses. And the output that Mary comes up with is XML that looks a little bit like this. This is a phrase of Gertrude Stein's from The Making of Americans. These are the words. These are the actual words. Repeating them is in every one. And if you can see, the wrapping tags basically give you. This is repeating in phonemes, essentially. This is then gives you the part of speech. This is a verb. It gives you a phrase boundary. So it says that this particular hump is it ends in a phrase. It's not the ending of a sentence or the ending of a paragraph. That would actually have a number. So that modeling the text in this way gives Mary the information that process needs in order to make the audio file. And we are interrupting that process and taking the XML and using it to do analytic processing and eventually visualization. The fifth aspect for Davis and so forth is that a knowledge representation is a medium for human expression, a language in which we say things about the world. And this is a very important part of this project. Essentially, the idea is that extracting this information from the text and modeling it as a knowledge representation, and then doing text mining and predictive classifications on that information is all well and good, but the results you get out of that are often commonly unreadable. It's difficult to actually sort through text mining analytic results. And so part of this project for us is creating an interface where that representative modeling is mapped back onto the original text that we were using. So we developed a tool. This is ProseViz, and it's still in very much of a development phase. And what you're seeing here are two, Stein used to write these portraits of her friends. And she knew a lot of people, but she was also, knew famous people like Picasso and Matisse, and they were her buddies, they were her friends, they came to her salon, and they all talked about important things. Or not important things as it could be. And she liked some of them more than she liked others, and she liked Picasso more than she liked Matisse. And this was important, and she had more respect for Picasso than she had for Matisse. And this, in some ways, is evident by these two portraits. They're basically prose poems. And what you're seeing here is the colors that you see. I know you can't read the text from here, but the colors that you see are the beginnings of phonemes. So mapped to different colors. And so these red blocks right here, essentially it says this one was one. And if you probably can see the four blurry bits. This is all the yellow. Was one, this one was one. That's right. This one was one. And so these are all red because it's was, one, was. It's the beginning of that sound. And what's interesting about this is you can immediately see that clearly it's repeated. That pattern is repeated right here. And if you know anything about these texts, this one's a lot more repetitive and boring because essentially she found Matisse to be not as creative as he could be or as innovative as he could be. She thought Picasso was much more innovative, but if you can see, this sound pattern gets repeated down here at the end because ultimately she didn't think that Picasso did enough. She thought he had more potential, but he didn't do enough. And this is represented in these poems. Now the predictive modeling, and I have nice little circles, I just showed you that anyways. The predictive modeling that we would like to do, and I'm sort of running out of time, so I'll just glance over this. One of the things we did, like I said, was to compare the tender buttons to this New England cookbook. There's an article written by a scholar who says this New England cookbook written about 1905 has many of the same sound structures as tender buttons. And so what we did was some predictive analysis where what you're seeing are those 10 texts that you just saw down here on the bottom. This is the computer predicting tender buttons, whether the text is looking out in terms of sound. And it doesn't include, this one doesn't actually include any word parts. It doesn't include any words. It's not comparing whether the words are the same between two texts. It's comparing whether the part of speech, the accent, the stress, all of these elements of prosody or stress or rhythm are similar. And what it actually finds is that it goes through and it's predicting of all the 10 texts, which are the ones that are most like tender buttons. So it chooses tender buttons. It can recognize that tender buttons is like itself. It's like, look here, I found it, yay. And then here's the New England cookbook. It's actually much higher than the others. This is Ulysses, and we could have thrown in more texts that were just like it, but we're still sampling here, we're still trying to figure it out. But it was interesting to see that of all the books, of these 10 random books, somewhat random, that also include other texts by Stein, it still points us to the New England cookbook as the most like tender buttons compared to the other ones. So we're still working with the algorithm here, and essentially if you go back to this idea about a medium of human expression, the goal of the project is to do this modeling to map it back on an interface like this that would eventually show the predictive model, where the predictive modeling is actually coming from, to allow human beings to get back into that data and actually make intelligent arguments about what is happening here with this, augmented by the computational analysis, but ultimately coming back to the human expression of how we make meaning with sound. That's it for today. Thank you. I ultimately used all my time, but do we have time for a couple questions?
Yes, absolutely. I have one. May I set up while you're answering questions?
Sure, yes, please do.
But can we go back? Sorry.
Sure, yes. Yeah. Which one would you like?
The prose.
Okay.
So, if I understand you, this is modeling the initial sound, whatever it is, of a word, and what are the horizontal units? Are these utterances?
Good question. The horizontal, you could do various things. So here we have it based on sentence. So this one is actually sentences. So where a period begins, where a period shows up basically. So each line is a sentence. You can model it any way that you want to. You can do it by phrase. Whatever Mary has decided is a phrase boundary. You could do it by paragraph. If you want to know the beginning of each, like if it's a prose text, and you really would just want to, you're interested in looking at the beginning of each paragraph. We're still working with this.
So it says phoneme. You mean initial phoneme?
This is the phoneme and then beginning.
Well, you've got tons of phonemes in each color. So my question is, it's the initial phoneme?
It's the initial sound. It's the initial sound of each phoneme. So, so you could actually do it by phoneme. You could do it by phoneme, or you can do it if you were really looking at, if you wanted to look at alliteration in a way that it's just the first consonant. That's what we're talking about when we're talking about the beginning of the phoneme. But you could also do it by the vowel sound, so that you just color by the vowel sound in a phoneme, or you can do it by the end of the phoneme as well. We're still playing with this interface.
You can do it line by line, like organize it so that it looks in the same format as the homework years.
Yeah, exactly. Go
Can you
ahead.
tell us anything about how similarity of stress patterns is measured?
How the similarity of stress patterns.
You have the bar graph showing how Mary is, or how your model is measuring
Right.
similarity of a variety of factors, and I'm just wondering how would one in third world country, how do you
Right.
measure the similarity between two patterns of stress?
Right. Well, so this is the way we did it. So we basically took the, and this is the part, so this is where the research lies, right? I mean, so part of the research is the algorithm that we're coming up with to do the predictive model. And that algorithm, the way that we're doing it currently is to average out phrase lengths, and the average out phrase length of those 10 texts turned out to be, I think, 16 phonemes. So some phrases were smaller and some, according to the Mary model, according to the MaryXML. Some of them were shorter, some of them were longer. The average was 16. And then we did a sliding window across those 16 and took the average of each phoneme according to that sliding window. So adding it up that way. And so again, I mean, this is an algorithm that we're kind of tweaking to figure out if that works. And part of my focus on this is to make sure there's always a user interface where we can check that. To be like, is this actually making sense in the way that I think it does? What's showing up? What are these patterns? Is it useful? Let's go back and tweak the algorithm. Let's go back and see if OpenMary can model this data a little bit differently.
I think one of the wonderful things with working with Gertrude Stein, you also have recorded.
Yes.
Gertrude Stein. Is there any plan in the future? I mean, because OpenMary conceivably is trained in a certain way by a certain corpus of corpora, whether it's spoken or written.
That's right.
Or maybe just general principles. I don't know. So is there any literature which has none compared to data that you can get or read and that you find that same kind of intermediate form?
Yes.
So that you're going both ways?
That's the next step. And then the other thing we're interested in doing, I mean, my background is in literary modernism, and the modernists have a huge collection of audio text files. The Library of Congress went out and just recorded them all. And so I would actually think it would be interesting to say, who influenced who's like who's not like whom, where are there other ways to analyze other bodies of, let's say, oral stories, or from groups of people to say that these patterns have strong influence on this literary group, or it seems to me there's a whole bunch of work that isn't done because we're not modeling the sound. But thank you.
Thank you.